Okay. Long jumper leaves the ground with an initial velocity of 10 meters per second at an angle of 30 degrees above the horizontal. So, I always like to draw them out. Leaves the ground. Going to go up, going to come back down. Let me know this. Okay. At an angle of 30 degrees. So here's my angle of 30 degrees right here. Initial velocity of 10 meters per second at that angle. So that tells me I have a vector because I have a magnitude, 10 meters per second, and I have a direction, 30 degrees above the horizontal. Here's the horizontal, 30 degrees. That means my 10 meters per second is along that angle. So that's my hypotenuse if I create a triangle here. So I want to dissect that initial velocity into x and y components because I don't have a VIX and a VIY yet. I just have a VI at 30 degrees. So let's go ahead and make our table. Put in all our variables, initial velocity, final velocity, acceleration, displacement, time.
You're on 4, right?
Correct, in a manner of speaking. Okay, so have all my variables here. Right now I'm splitting up my VI, my initial velocity, so I have a VIX and a VIY. So the vertical component, the up and down component, is going to be your VIY. The horizontal component is going to be your VIX. That's a Y, by the way. There we go. So, to solve for my VIY, it's my opposite side. Which trig function should I use? Sine. Sine of the angle, which is 30 degrees, equals opposite, VIY, over hypotenuse, which is 10. Sine of 30 is 0.5. Multiplied by 10 gives me 5 for my VIY. Still the same units, meters per second. Units are important. Put the units on the test. Do not just put numbers down. If you ever put a number down, make sure you have something after it. Make sure you know what that something is. Adjacent. I can use cosine of 30 degrees. Equals adjacent, VIX over hypotenuse, 10 meters per second. Cosine of 30 times 10 gives me 8.7. It's 8.66. We call it 8.7. So my VIX, 8.7 meters per second. All right, so I split those up. Now I can fill in the other things I know. Acceleration in the x direction. I'm assuming no air resistance, so what's my acceleration going to be? 0. Y. Negative 9.8 meters per second squared. What else do I know? What about my VFX?
It's the same as VI.
Same as VI, 8.7 meters per second. I have no change in velocity, so my velocity stays the same the whole time. dx I don't know, t I don't know. Questions they're asking. Determine the time of flight, so I want to find t. Horizontal distance, that's my dx, my displacement in the x direction. And peak height of the jumper. So remember, peak height is right here in the middle. I want to know how high he goes before he comes back down and hits the ground. So I only have 2 variables over here on the right side, on the y side. I want to be able to solve for time over here. So what other variable can I know? He started on the ground, right? Displacement is going to be 0. He started on the ground, he ended up on the ground. Remember, displacement is the length between start and finish. In the y direction, started on the ground, ended on the ground, so my displacement will be 0 meters. Okay, now I have enough variables I can solve for time. So I'm going to use that same equation that I usually use, that first one, because I have displacement, I have acceleration, initial velocity, solving for time. So I want to use the equation that includes displacement, initial velocity, time, and acceleration. That's that first equation. So, plugging in variables, first of all. Displacement 0, put a barrier here, equals my initial velocity is 5 meters per second, multiplied by time, plus 1/2 times my acceleration is negative 9.8 meters per second squared, multiplied by time squared. So all that I did was just plug in my variables. Now, 1/2 times negative 9.8 meters per second squared gives me negative 4.9 meters per second squared. So I'm just going to go through step by step. 0 meters equals 5 meters per second times time, plus negative 4.9 meters per second squared times t squared. What can I do with this negative 4.9 meters per second squared times t squared?
Both sides.
I can add it to both sides. It's a negative, so I can do plus 4.9 meters per second squared times t squared. Same over here, plus 4.9 meters per second squared times t squared. So I'll end up with 4.9 meters per second squared times t squared equals 5 meters per second multiplied by t. What now? Divide each side by time. The reason I do that, gets rid of time over here, gets rid of one of these over here, leaves me in 4.9 meters per second squared times t. Put a divider here. 4.9 meters per second squared multiplied by t equals 5 meters per second. Now all I have to do is divide each side by 4.9 meters per second squared. Five divided by 4.9 gives me a little over 1. 1.02. Checking the units, meters cancels out, seconds cancels out, leaves me with 1/seconds on the bottom, flip the reciprocal to the top, leaves me in seconds. So I end up with 1.02 seconds. All right, so we solved the first question. Determine the time of flight. Throw that back in. All right, so next question, horizontal distance, the dx. That's a pretty easy one. Remember our acceleration in the x direction is 0. So when we're dealing with this same equation, d equals dix times t plus 1/2 a t squared. Our acceleration is 0, so that eliminates this whole part of the equation. It's just going to be like the displacement form of my velocity equation. Velocity equals distance over time. If I solve for displacement, it's going to be displacement equals velocity multiplied by time. So in this case, dx equals 8.7 meters per second multiplied by 1.02 seconds. Seconds cancel out, leaves me in meters. A little over 8.7.
8.87.
Oh.
Excellent. So 8.87 meters will be our displacement in the x direction. In other words, from where he took off to where he landed, 8.87 meters. Now, that answers 2 of the 3 questions. The last question, peak height of the long jumper. Where is the peak height, first of all? Right in the middle. Right here. So, it takes him 1.02 seconds to get from here to here for a displacement of 0 in the y direction. How long does it take him to get from here to here? What is it?
Half the time.
Half the time, right? What is that, 0.501?
0.51.
0.51? Oh, that's right. All right, so new time I'm going to use is 0.51 seconds. That takes me from here to the maximum height. That's going to change my displacement in the x direction. Remember, in order to get back to the ground, my time has to be 1.02. So if I use this 0.51, my dy is going to change. So I'm going to call that dy maximum. That's my new maximum displacement in the y direction. That's what I'm solving for. Using this time, gravity doesn't change, right? That would be odd if it did. But gravity stays the same, negative 9.8 meters per second squared. My initial velocity stays the same. He still jumped with the same amount of initial velocity in both the x and y directions. So that stays the same, that stays the same. New time, I solve for my displacement. So, using that same equation, dy equals viy times t plus 1/2 ayt squared. I'm going to plug in. I'm solving for dy, so it's already set up for me. Not going to be too hard to solve. No algebra involved, just plugging in numbers. So viy, 5 meters per second, multiplied by time. We make sure you use that half time every time, so that's 0.51 seconds. Plus 1/2 times negative 9.8 meters per second squared times t squared, which is going to be 0.51 seconds squared. Now, start doing some multiplication. 5 times 0.51 gives me 2.55. Second cancels out, leaves me in meters. Dy equals 2.55 meters plus negative 4.9 times 0.51 squared. Negative 4.9. Negative 1.27. 1.27 seconds squared cancels out, leaves me in meters. 2.55 plus negative 1.27.
1.28.
1.28, thank you. 1.28, already meters on both, so meters. There's my maximum height, 1.28 meters. Make sense? Jumped at a fairly shallow angle, a 30-degree angle, so most of his initial velocity was in the x direction. Still had 5 meters per second in the y direction. So it's the same problem as if I said someone jumped straight up in the air with an initial velocity of 5 meters per second. Go up to that same height of 1.28 meters. Come back down. Final velocity, by the way, negative 5 meters per second. That's not always the case if they don't come down to the same level, but in this case, started from the ground, ended on the ground. So, had 5 meters per second going up, slowed down to 0, accelerated again, heading back down over the same distance. He had the same acceleration, so his final velocity would be the exact same, just in the opposite direction. Good?
Yeah.
All right. Shut that thing off.
You're recording.